Okay, so this time I will talk about atomic mass and atomic number, and isotopes. If you watched my last video on atomic structure, you'll see that I completely forgot what the charge on an electron was, not because I don't know, but because my brain has frazzled in isolation. But Alexa tells me that it is minus 1.6 times 10 to the minus 19 coulombs, and you don't really need to know what coulombs are. No, you do actually. I've already taught you what coulombs are when we did electricity. Okay, so you know what a coulomb is. Okay, so charge on an electron is minus 1.6 times 10 to the minus 19 coulombs. Therefore, the charge on a proton is 1.6 times 10 to the minus 19 coulombs. So the difference there, as you can see, is for an electron it's negative, for a proton it's positive. Right, getting on with this video though, atomic mass. Now, I'm going to use the example of carbon just as I did in our the meeting that we had, purely because I can remember the numbers by heart. That and lithium. So if I'm talking about carbon, you'll see it written in the periodic table like so. And this number, that is your atomic number. That is your atomic number, and this number here is your atomic mass number, or relative atomic mass number and relative atomic number. You'll notice that the word relative appears quite a lot in this topic. Now, what do they actually mean? So the smaller number, i.e. the atomic number, always tells you the number, I'm going to put that for short, so I don't have to write number all the time, number of protons that you would find in the nucleus of that atom. So for carbon, it will always have 6 protons. As I mentioned before, the number of protons in an atom defines what element that atom is. You won't have a carbon atom with 7 protons or 5 protons. Okay, that would make it a different element, just like your DNA defines who you are. The number of protons kind of defines what element an atom is. Okay, so the atomic mass number, that is the number of protons and neutrons. So in this case, for carbon 12, the atomic mass number is 12. That doesn't mean there are 12 protons and there are 12 neutrons. It just means there are 12 altogether. We already know how many protons there are from the atomic number. So there's 6 protons. So if 6 of this 12 are protons, how many can be the neutrons? Well, 6 as well. Okay, it doesn't always, it's not always quite as nice as that. But in this case, 6 protons and 6 neutrons. Okay, so that's what they tell you. I know these words are quite similar. It's always atomic number in there, but this one has atomic mass number. The only way I can think to help you understand or help you remember which way round it is that when we're talking about mass, we're talking about how much mass is there in the nucleus altogether. And if you were going to do that, you wouldn't just add up the number of protons in it, would you? Because you know that there are also neutrons in the nucleus. So you would add up the total number of protons and neutrons, and that tells you the relative mass. In fact, you know, that is why the word relative is important. The relative atomic mass number and the relative atomic number. Even though a lot of the time we don't use it. We don't use the word relative when we're talking about the atomic mass number and atomic number, but it is technically important. So if I give another example, lithium, because I can remember it, lithium 7,3. This is my atomic number, so that means there are 3 protons in lithium. Always, every single lithium atom that exists has 3 protons in the nucleus, and this is the number of protons and neutrons. So if 3 of these 7 are protons, that leaves me with 4 neutrons. Okay, so it's quite easy. You could do that with any of the elements of the periodic table. You might want to look one up on Google if you don't have one in your book. I highly recommend you stick one in your book. Obviously, your planners this year didn't have a periodic table in. No idea why. Not all that helpful, but hey ho. So that's how you know the difference between atomic mass and the atomic number. Now I need to talk about isotopes. So an isotope is, well, if I had 2 atoms that are the same element, but they have different numbers of neutrons in their nucleus, they would be isotopes of each other. Now, remember, they have to have, if we're talking about carbon, imagine we were talking about 2 carbon atoms, both of them will have 6 protons in, otherwise they won't be carbon, okay? But they might have different number of neutrons in, so the obvious example is carbon 12 and carbon 14. You'll notice 6 and 6 both have 6 protons, but as we worked out before, carbon 12 has an additional 6 neutrons. How many must carbon 14 have? It must have 8. So carbon 14 has 2 more neutrons than carbon 12 is. These 2 are isotopes of each other. Can you actually see that? I hope you can. Yeah, you can see that. They are isotopes of each other. You can never have carbon 12 and lithium 7 as isotopes of each other. It has to be of the same element, otherwise they won't be isotopes. Okay, so just a reminder that if you have 2 atoms that are of the same element but differing numbers of neutrons in their nucleus, then they are isotopes of each other. So, you know, that's quite straightforward. I'm just going to make one up for lithium. Lithium 3. Okay, I've completely made this up. So this one, lithium 8, has 1 more neutron than lithium 7 does, so they are isotopes of each other. Sometimes in an exam, they will actually give you, they won't tell you what the they won't tell you what the element is. So they could use the letter X. I've seen them use X or Z. So obviously there's no element in the periodic table that has the symbol X. So in place of X would be, for example, lithium or carbon, but you don't know what it is. They won't give it to you. But what they could give you is, I'm making these numbers up, by the way, so don't think that these are real examples. I don't know. So they might say, are these 2 isotopes of each other? First thing to check, do they have the same atomic number? I.e., do they have the same number of protons in them? No, they don't. Therefore, actually, this shouldn't even say X because these are not the same element. This would be Z, for example. It would be, because they can't be the same because there's different numbers of protons. Doesn't matter if these 2 numbers are the same. These 2 have to be the same. So they can't be isotopes of each other because they're not even the same element. Okay, another example. Are these isotopes of each other? Well, do they have the same atomic number? Oh, yes, they do. So we know they're the same element. Do they have the different numbers of neutrons? They do. Therefore, they're isotopes of each other. Okay, one more example. Are these isotopes of each other? Well, no, they're exactly the same. It's the exact same. There's the same number of protons and neutrons in both. So that's just 2 atoms of the element that are identical. Okay, so hopefully that's helped you to understand what isotopes are. If you have any questions, obviously do email me or write in the Microsoft Teams group so that I can help you. But then that's it. And the next one I'll do radioactivity, and I'll talk about nuclear radiation.